This question is asking us, is heat absorbed or released when a gas condenses? Is heat absorbed or released when a gas condenses? The key word here is condenses. Okay, now let's look at the states of matter. So remember, when you see something like this, it has a shape and a volume, so it is a solid. Think of it like an ice cube. It looks like an ice cube, green ice cube. Now, the molecules here have just enough energy to vibrate in place, but they are stuck in place. They don't move. And they are close to each other. In a liquid, the molecules can move. They are not stuck to each other. They can slide past each other, but they are still close to each other. It does not have a shape. Think of the ice cube melting. But they have more energy than the molecules here, so they can slide past each other. And the liquid has a volume. It does not have a shape, but it has a volume. But more relevant to the question at hand, they have more energy here than here. More energy as a liquid than as a solid. The process of going from a solid to a liquid is what we call melting. So the molecules need to gain energy for that matter to become a liquid. We need to give them that added energy that they need to be able to slide past one another. Now, if we examine the case from here to here, now we have a gas. Okay. You notice that the molecules occupy the whole space that's provided to them. Now these arrows are representing the velocity. Notice here that the velocity is much larger than it is here. So the molecules have more kinetic energy, more energy. They move faster. They occupy the whole space and they are further apart. So a gas does not have a volume and does not have a shape. But the molecule have the most energy from these three different states. So to get that additional energy they need to be a gas, when they move from the liquid phase, they need to gain that energy. We need to provide them with that added energy. And we call the process vaporization or evaporization. Okay, so they need to gain energy when they go to the state where they have the most energy. Now, when the reverse happens, like when you take a shower and then go to the mirror and find water over the mirror, that's condensation. That's the water vapor coming out of the shower head. Some of it condenses, and that's what you find on the mirror. So here, the reverse is happening. The molecules are going from a state where they have a lot of energy to a state where they have less energy. So they need to get rid of that extra energy for it to become a liquid. So during condensation, the molecules lose energy. They get rid of energy. We need to take away energy from them. Now, similarly, when a liquid turns into a solid, solidification we call it, or freezing, now again, the molecules have more energy here than here, so they need to get rid of that extra energy during that process. So they get rid of it to the environment, or we have to extract it from them some way, some mechanical way. So if we go back to the question here, since the gas is condensing, so heat must be released because the molecules have to get rid of that excess energy. So the heat must be released. Note, for example, condensation, actually not condensation, freezing here, During spring, sometimes when there is a late frost, in places that grow oranges, for example, like in Florida, what they do, they cover the oranges with water before the freeze. So as the water freezes, it's going to give off energy, and so energy is going to be released by the water and is going to help prevent the oranges from freezing.